Soft whale songs drift through the vast dark ocean, carrying secrets across distances wider than entire states. What if these ancient voices could guide you into sleep? Tonight, we drift into the peaceful science of whale songs and the quiet rhythms of the deep sea. Welcome to Sleepy Science Nights, where we explore the quiet wonders of our world in a slow, gentle voice meant to guide you toward rest. Tonight, we drift into the deep ocean, a place where light fades, currents whisper, and sound becomes the language of life. This world is not silent. Far below the waves, whale songs travel across incredible distances, carried by layers of warm and cold water. These sounds move through the deep in ways that seem almost dreamlike. Some calls can wander for more than hundreds of miles, shaped by underwater valleys, soft seafloor plains, and wide open stretches of saltwater wilderness. In this calm journey, we will explore how whales learned to sing through their long evolutionary history and how their voices create one of the most peaceful natural soundscapes on Earth. We will look at the strange acoustics of deep water, the hidden pathways that guide sound, and the night music of other ocean creatures who hum, click, or pulse in the darkness. Along the way, we will see how the physics of sound becomes both a tool and a mystery in the underwater world. We will hear how scientists listen to distant echoes and why these gentle tones help humans fall asleep. This is a soothing, documentary-style exploration filled with surprising facts told in a warm, bedtime science voice. The pace will be slow, steady, and soft, like the calm rise and fall of waves. So settle into a comfortable position. Let your breath become gentle. Think of the dark blue sea stretching out farther than the eye can see. Think of voices that travel through it like threads of silver drifting in quiet water. And when you are ready, we will begin our peaceful dive. If you enjoy Sleepy Science Nights, remember to subscribe so you can drift into more calming journeys, one soft fact at a time. Settle deeper into rest as we drift backward through time, far beyond the modern oceans we know. Imagine the world millions of years ago, when the ancestors of whales still walked along ancient shorelines. Their bodies moved between land and shallow water. Their limbs were sturdy, their spines flexible, and their senses shaped for a world filled with sunlight and air. Yet something in their future called them toward the sea, toward deeper rhythms, and toward a new language that would one day echo across wide ocean basins. The story of whale songs begins long before any true whale existed. It begins with early mammals, who discovered that water could carry sound in ways the land never could. These ancient creatures stood at the threshold of a vast transformation. Over many generations, they would trade running for swimming, legs for flippers, and a life guided by sight for one guided by sound. Their world expanded from river mouths and coastal flats into open water, where distance and darkness demanded new strategies for survival. Imagine an early ancestor slipping beneath the surface. Sound wrapped around it in a different way. Underwater, vibrations moved faster and traveled farther. A simple grunt or splash could carry through warm shallows for surprising distances. Over time, these faint noises became clues, signals that hinted at food, danger, mates, or shifting tides. Slowly, the ocean invited these early mammals to use sound not just for survival, but for communication. As their bodies changed, so did their hearing. Their ear bones grew thicker, helping isolate underwater vibrations from the outside world. They developed new internal spaces that enhanced sensitivity to low frequencies. This meant they could detect deeper tones, ones that rolled through water like distant thunder. These changes did not happen all at once. They appeared gradually, shaped by nature's quiet patience, much like the slow sculpting of seafloor canyons by drifting currents. Now picture a coastline where small groups of early whales gather. Their bodies are more streamlined than their land-dwelling ancestors, yet still different from the graceful giants we know today. These creatures are learning to use sound in ways no other mammals have ever done. Each soft vibration they produce becomes part of a new acoustic world. A low hum might help keep track of family members in murky water. A throaty pulse might warn others of predators. These were not songs yet, but they were the first threads of a language forming over deep time. As the oceans changed, so did the whales. Sea levels rose and fell. Temperatures shifted, currents found new paths across the world. Through all this, early whales continued refining their underwater voices. Their calls became more nuanced. Their bodies grew larger, allowing them to create even deeper tones. In the ocean, size influences voice. A bigger body can support larger resonating chambers. That means lower sounds, and lower sounds can travel astonishing distances. Imagine the first whales discovering this by instinct. A low-frequency call slips through a warm surface layer, dives into cooler water, and glides outward for miles. The caller may never know how far its voice has gone, but the ocean knows. It carries the message forward, letting the sound drift around underwater ridges and through quiet, deep channels. Every call becomes a small experiment in physics. Every silence becomes a moment of learning. This evolutionary path slowly produced two major groups of whales. One group developed baleen plates and enormous bodies. These would become the singers of the deep, known for long, haunting melodies. The other group developed teeth and remarkable echolocation abilities, using ultra-precise bursts of sound to navigate and hunt in darkness. Both groups found unique ways to speak with the sea. The baleen whales, the singers of our story, began shaping calls that were more than simple signals. They created long, drawn-out tones. They layered soft moans with rising notes. They linked pulses into patterns. These were the earliest versions of whale songs, still crude compared to the complex melodies we hear today, but already hinting at something remarkable. Sound became their compass, their memory, and their connection to one another across vast distances. Imagine a young whale gliding through ancient water. Its voice resonates through its body. It releases a low note, and the surrounding water embraces it. The note spreads outward, carried by currents. Perhaps another whale answers with a deeper tone. This early duet becomes part of a growing tradition, a tradition that will evolve into some of the most peaceful sounds on Earth. The whales were not only learning to make sounds, they were learning to listen. Their auditory systems grew more refined, able to detect distant vibrations even when the ocean was restless. A call that traveled for several miles could still be recognized. A faint echo bouncing off a seafloor shelf could hint at the shape of the world around them. Early whale families may have used simple acoustic patterns to maintain bonds. A mother might hum softly to her calf, guiding it through dim water. Adults might communicate during migrations, sharing location cues or warning of shifting conditions. Over time, these interactions would expand into fully formed acoustic cultures. Unique sound traditions passed from one generation to the next. Close your eyes for a moment and imagine those first songs. They would have been slow, gentle, and resonant. There would be a deep calmness in them, shaped by bodies built for the quiet depths. These tones were not designed for performance. They were shaped by survival, by connection, and by the nature of the ocean itself. When you listen to whale songs today, you hear echoes of this ancient transformation. You hear the outcome of millions of years of adaptation, migration, and communication. You hear the story of mammals who left the land behind and found a new home in the deep. Their voices have carried through time, just as they carry through water, steadily, peacefully, and with a soft sense of wonder. As you drift deeper into rest, think of these early whales learning to speak the ocean's language. Their quiet songs were the first notes in a long symphony that still continues. The deep sea welcomed their voices, shaped them, and sent them outward across miles of calm, blue darkness. And tonight, those ancient beginnings can guide you gently toward sleep, one soft tone at a time. Let your breath settle as we drift downward into the deeper layers of the sea, far below the bright surface where light wavers and dances. Down here, the world becomes blue, then darker blue, and then a gentle near darkness that feels endless. This quiet realm is where sound becomes king. It is where whale songs stretch into remarkable distances, turning the deep ocean into something like a vast acoustic cathedral. When we explore this underwater world, we discover that sound behaves differently than it does in air. In water, sound travels faster, farther, and with a clarity that can be almost haunting. Imagine a long, slow note drifting out from a whale's body. The note moves through the water, carried by conditions shaped not by walls or ceilings, but by temperature, pressure, and the hidden architecture of the sea. The ocean itself becomes a giant resonating space, guiding each vibration on a long journey. The topmost layer of the ocean, warmed by sunlight, is full of turbulence from waves and wind. This warm surface layer can scatter sound, making some calls fade quickly. But as you drift deeper, the temperature begins to drop. The water becomes cooler, denser, and more stable. This is the beginning of what scientists call the thermocline, a band where warm and cold layers meet. The change is gentle but important. As the temperature shifts, the speed of sound shifts too. This helps guide certain tones downward, like soft threads sinking deeper into the sea. Continue drifting down. Below the thermocline, the water becomes cold and calm. There are few disturbances. Here, sound can travel with surprising efficiency. Low-frequency tones, the kind baleen whales specialize in, can glide through this region almost effortlessly. These deeper layers form what is known as a natural sound channel, a place where vibrations may travel for dozens or even hundreds of miles without losing their strength. It is as if the ocean has created a quiet hallway just for sound, a passageway where notes can wander for astonishing distances. Imagine a blue whale releasing a long, low moan. The sound vibrates through its massive body, then enters the water around it. The call sinks downward into the deeper, cool band. Once inside this natural channel, the call begins to travel outward in every direction. No walls are needed to guide it. The ocean's own temperature and pressure gradients create the boundaries. The call drifts calmly, slowly expanding like a soft ring of energy. It might travel farther than the entire width of a large coastal state, reaching ears the original caller will never meet. To whales, this ability is more than impressive. It is essential. In the dim world of the deep sea, vision fades quickly. Even the largest creatures can become silhouettes only a short distance away. But sound cuts through the darkness. A whale can learn about its surroundings from distant echoes, changes in resonance, or shifts in tone that reveal the presence of underwater valleys, ridges, or seamounts. Some whales may even sense the slight acoustic signatures of shifting currents, guiding them as they migrate through thousands of miles of open water. Picture the deep ocean floor beneath you. It is not flat. Instead, it is sculpted by underwater mountains, trenches, and long sweeping plains. When whale songs travel through the ocean, these features shape the sound. A deep trench might act like an amplifier, sending a call upward. A tall ridge might reflect part of a note, delaying it slightly before it arrives at a listener's ears. Every geographic feature contributes to the ocean's acoustic personality. The result is a soundscape full of subtle patterns, waves and reflections that whales navigate with ease. Human ears are not as finely tuned to this world. If you or I were floating in the deep ocean, we might hear only a distant hum or a faint moan carried by the water. But whales experience this environment with profound precision. They can detect minute changes in frequency. They can tell where a sound is coming from, even in near darkness. And they can send signals that reach across incredible distances without shouting or straining. Their voices are built for the sea. As you float deeper into this imagined space, notice how the silence feels different here. It is not empty. It is full of potential energy waiting to carry the next vibration. The quiet is soft and steady, like the hush of a great cathedral when no one is speaking. Every gentle sound becomes clearer. Every subtle shift becomes meaningful. This is the space whales were made for. Whales take advantage of this acoustic environment in many ways. Some species send calls to coordinate movement among family members. Others use sound to attract mates across wide ranges. A single long note might carry farther in the deep than several smaller notes at the surface. Because of this, whales have evolved to use sound with remarkable efficiency. They know how to match their tones to the depths around them, choosing pitches that travel best through the water conditions of their region. Even shifting weather patterns can influence how far a call travels. A storm passing above may mix warm surface water, altering layers below. The natural sound channel may rise or fall slightly over seasons. And yet, whales continue to sing, adapting instinctively to the changing ocean. Their voices are shaped not only by biology, but by the physics of their environment. They are living instruments built to perform in a space designed by nature itself. Imagine now a quiet moment in the deep. A whale releases a call so low you feel it more than hear it. The note glides outward, finding the calm band of water where it can travel farthest. The ocean accepts the call, stretches it gently, and carries it along. Somewhere far away, another whale lifts its head slightly and listens. In the dim water, the distant call becomes a soft thread connecting two beings separated by an unimaginable distance. This acoustic cathedral is not static. It shifts with currents and seasons. Yet it remains one of the most remarkable natural environments on Earth. Each tone, each echo, each faint vibration becomes part of a vast underwater mosaic. And for whales, this space is home. As you relax into the slow pace of this chapter, let yourself imagine drifting through these quiet layers. Feel the calm coolness of the deep. Feel the steadiness of the water. Imagine whale songs traveling through this grand, peaceful world. These long, gentle notes are shaped by science, yet they feel like lullabies written by the sea itself. Let your breathing slow as we drift into a new layer of underwater wonder. This time, we gently explore the voices of whale families and the remarkable truth that whales do not all speak the same way. Their songs and calls change depending on where they live, whom they travel with, and what traditions their ancestors passed down to them. In this calm chapter, we explore the quiet miracle of whale dialects, unique acoustic cultures shaped by generations of gentle voices moving through deep blue water. Imagine a wide stretch of ocean where a pod of humpback whales glides slowly beneath the surface. They stay close, weaving long, gentle shapes through the water like a slow-moving constellation. As they travel, they share soft calls with one another. These calls are not random. They carry meaning. They carry emotion. They carry identity. The whales can hear differences in tone and rhythm that human ears would barely notice. To them, these subtle variations are as familiar as the sound of a family member's voice. Whale dialects form the same way human regional accents do. They emerge over time as groups learn from one another. A young whale listens to the adults around it. It hears the rising patterns of notes, the gentle pauses, and the flowing rhythm of its pod's song. Over years, the young whale learns to repeat these patterns, and as it grows, it adds small variations of its own. These little changes, passed along through many seasons, slowly shape a unique acoustic culture. Different whale families living hundreds of miles apart may develop songs that share the same general structure but feel distinct in tone. Imagine two groups of humpbacks separated by a wide open ocean. They may both begin their songs with a long, low hum, followed by a series of soft, rising chirps. Yet the timing, the spacing, or the emotional weight of these notes may differ. These distinctions do not confuse the whales. Instead, they enrich the vast soundscape of the sea. Every region becomes known by its own musical character. Some whales change their songs over time. Humpbacks, in particular, are known for seasonal shifts. A song that was common during one winter may fade the next year, as new variations spread through the population. These changes occur gently, like slow, evolving currents in a quiet bay. One whale introduces a new phrase. Others imitate it. Soon, an entire community adopts the updated pattern. The result is a song that belongs to that group during that specific moment in time. It is almost like a memory carved into sound. Other whales hold on tightly to their traditions. Killer whales are famous for their stable family dialects. A specific pod may use the same pulse patterns and whistles for decades. These sounds help maintain strong family bonds. If members become separated, they can still find one another by listening for the familiar accent of their pod. Even distant relatives who have not traveled together for years can recognize their shared lineage by sound alone. As you drift deeper into this idea, imagine the ocean not as one continuous world, but as a vast patchwork of acoustic neighborhoods. Each region has its own tone, its own rhythm, its own patterns. When whales migrate, they may pass through areas where the calls sound different. To them, this is as noticeable as hearing unfamiliar voices along a long mountain trail. Yet the transitions are gentle because the ocean blends everything into soft, continuous gradients. Dialect differences are not only cultural, they also reflect variations in environment. A pod that lives in areas with steep underwater cliffs may favor different types of calls than a pod living in flat, deep basins. The shapes of their surroundings influence how sound travels. Certain tones may carry better in narrow valleys. Others may spread farther over open plains. Over generations, whales adjust to these little acoustic quirks. Their voices become tuned to the landscapes they know best, much like birds shaping their songs to match the forests they live in. Another remarkable truth is that whales can learn from one another across vast distances. If a new song variation becomes especially appealing, it may spread across entire oceans. This has been witnessed among humpback whales in the Pacific. A pattern that begins with one group near an island may eventually travel east or west as different pods adopt it. The spread is slow but steady, like a shared lullaby drifting through a community that spans hundreds of miles. These acoustic traditions are powerful. They create identity for each pod. They support cooperation during travel. They help mothers guide calves. They allow distant groups to communicate when needed. And they make the world of whales feel alive with diversity. No two regions sound exactly the same. No two families sing precisely alike. Close your eyes and imagine floating in deep water with your ears gently tuned to different calls, drifting across the sea. To one side, you hear the rolling low notes of a nearby pod. To the other side, farther away, you catch the soft echoes of a different group whose dialect rises more sharply at the end of each phrase. These layers overlap beautifully. They form a sonic tapestry woven across miles of calm blue darkness. Think of how comforting this must be to the whales. A calf, only a few months old, may follow its mother through dim underwater corridors. Every call she makes, every subtle rumble, becomes a guiding beacon. To the calf, her voice is home. As the calf grows, it begins to contribute its own sounds, tiny and imperfect at first, but slowly learning the patterns that have shaped its family for generations. Even adults take comfort in the familiar accents of their pod. When a whale dives deep into cooler layers, the last sound it hears from above may be a call from a close companion. That call carries reassurance through the quiet. It tells the whale, "You are not alone. Your family is near. The path ahead is safe." This idea of belonging through sound is one of the most peaceful aspects of whale life. In a world so vast that even the largest living creatures can disappear into darkness, their voices connect them across distance. They build bridges through the water. They create closeness where sight cannot reach. As you continue to drift into rest, imagine these dialects moving like soft musical currents. Think of pods separated by dozens or hundreds of miles, each singing their own version of a shared melody. The ocean becomes a choir of gentle, low notes, each pod offering its distinctive voice. Together, they create one of the calmest, most mesmerizing natural soundscapes on the planet. Settle gently as we drift into the quiet science behind the way sound moves through the ocean. In this chapter, we explore how whales use the natural structure of the sea itself to send their voices across great distances. These movements may feel mysterious, yet they follow simple and soothing principles of physics. And when we understand these principles, the calm beauty of whale songs becomes even clearer. Imagine floating just below the ocean's surface. The water here is warm from sunlight that sinks downward during the day. Even in the gentle dark of night, this warmth lingers. The upper layer of the sea feels alive with motion. Waves stir it, winds brush above it, small fish dart through it. All of these activities create little distortions in the water, bending and scattering sound. Whales know this instinctively. They understand that their voices behave differently near the surface than they do in deeper, cooler layers. To understand why, imagine sound as a traveler moving through the water. In warmer water, this traveler moves faster. In cooler water, it moves more slowly. When sound passes between warm and cold layers, the shift in speed causes the sound to bend, almost the way light bends when it passes through a glass of water. The ocean is full of these boundaries. Each one shapes the path of a whale's call. Now sink a little deeper. As the warm surface fades behind you, the temperature begins to drop. The change feels gentle, as though the ocean is calming itself with each passing foot. This region, where warmth and coolness mix, is a transition zone that influences the movement of sound in delicate ways. The slow bending of vibrations in this band can help guide a call downward, lowering it toward deeper water, where the conditions are more stable and predictable. Below this transition, the ocean becomes colder and denser. Currents slow. Light fades, and the water grows quiet. Here, sound behaves differently. Because the temperature stays steadier, sound waves can glide through this region with remarkable efficiency. The vibrations do not scatter much. They do not distort easily. Instead, they stretch outward in smooth arcs, traveling with a gentle grace. Whales take advantage of this natural structure. Many species create low-frequency sounds that sink into these cool layers, allowing their calls to travel across dozens or even hundreds of miles. These low notes move through the deep with little effort, held by the water as though carried carefully through a long hallway engineered by nature itself. Picture a blue whale drifting in deep water. It releases a soft, rumbling call. The sound leaves its body and spreads outward. Because the whale is in cool, dense water, the sound moves slowly and cleanly, without the scattering that happens near the surface. This gives the note clarity. It allows the call to travel far without losing its shape. A distant listener might hear it as a calm, rolling hum that rises and falls over several seconds. The speed of sound changes not only with temperature, but also with pressure. As you descend deeper into the sea, the pressure increases steadily. This higher pressure can make sound move faster, balancing out the cooling temperature. When these two influences match in just the right way, they create a sound channel, a band of water where sound can travel with extraordinary efficiency. This channel twists and bends as it wraps around the planet, influenced by currents, seasons, and the shape of the seafloor. Imagine this channel as a soft ribbon of water stretching around the world. A whale that releases a call within this ribbon sends its voice on a long journey. The sound moves outward, like a soft breath traveling through still air. It may drift for dozens of miles before it reaches a listener. In some rare conditions, depending on the region, these deep tones may wander for far longer. The warm and cold layers above and below the channel act like natural barriers that reflect the vibrations inward. This makes the sound stay inside the ribbon, bouncing softly between temperature-defined boundaries. The result is a quiet and elegant pathway for communication. To the whales, this channel is as real and as valuable as a mountain path is to a traveler on land. They may not understand the physics the way humans do, but their instincts guide them to use these underwater corridors with remarkable skill. The ocean also changes with the seasons. In warmer months, Sunlight warms the upper layers more deeply, shifting the boundaries between warm and cold water. This can cause the sound channel to rise or fall. In cooler months, storms may churn the surface, blending layers together. Yet even with these changes, whales adjust. They may dive deeper to send long-distance calls during certain times of the year or move closer to the surface when communicating with nearby family members. Their voices follow the hidden maps drawn by temperature and pressure. Picture the movement of a long whale song in this shifting environment. The song begins near the surface, where the whale takes a breath. Then it dives, releasing a call in the quiet blue beneath. That call slips downward as it bends through layers of warm and cold water. Finally, it settles into the deeper ribbon of sound movement. In that calm band, it glides effortlessly away. The ocean becomes a patient messenger, carrying the whale's voice toward distant listeners. This entire process may feel abstract, yet it has an almost magical simplicity. Warm water makes sound travel quickly. Cold water makes it travel slowly. Pressure pushes it faster. Together, these forces shape the path of each call. The ocean becomes both a composer and a conductor, guiding each tone across its vast blue stage. As you breathe gently, imagine yourself floating in this layered landscape. You feel the warmth near the surface. You sense the coolness below. You imagine sound moving through these gentle gradients, finding pathways shaped by nature's quiet design. Each whale call becomes a wandering traveler, drifting through a cathedral of temperature, pressure, and stillness. Even at great distances, whales can sense the faintest vibrations. They can interpret these changes with precision. Humans find difficult to imagine. A small shift in frequency might tell them the direction of a companion. A subtle echo might reveal the presence of a seamount rising from the sea floor. A quiet response from miles away might guide them through open ocean during a long migration. All of this depends on the warm and cold layers of the sea. Without these temperature gradients, whale songs would not travel the same way. They would lose their far-reaching calmness. The deep ocean would feel less like a sound cathedral and more like a world of scattered echoes. As you drift toward sleep, think of these layers folding gently around you. Warm and cold, light and dark, pressure growing slowly with depth. Imagine sound slipping through them like a soft ribbon, carrying a peaceful message across miles of deep blue quiet. Let yourself drift deeper into stillness as we explore one of the most peaceful and astonishing mysteries of the sea, the ability of whale songs to travel across vast ocean spaces. Some calls wander through the deep for distances wider than entire states. Some seem to glide so far that the caller and the listener may never meet. These long-distance songs turn the ocean into a world stitched together by sound, carrying quiet voices through hundreds of miles of blue darkness. Imagine a humpback whale drifting in cool, deep water. Its massive body is relaxed, floating with slow grace. When it releases a long, low note, the sound vibrates through the surrounding water like a gentle tremor. The note is deep enough that you feel it with your body as much as you hear it. It spreads calmly outward, sinking into the layers where sound can travel most efficiently. Within moments, the note is already far from where it began. Whale songs are uniquely suited for long-distance travel because many species produce extremely low-frequency tones. These low notes, often lower than what human ears can easily detect, behave like slow rolling waves. They do not fade quickly. Instead, they stretch outward, slipping through the deep layers of the sea with patience and steadiness. A blue whale's lowest call might last only a handful of seconds, but the sound wave can travel across dozens of miles before losing its shape. In certain ocean conditions, the call may wander far beyond that, drifting through deep water channels shaped by temperature and pressure. Picture the ocean as a series of stacked layers. Near the surface, voices scatter and weaken as waves and wind create moving patterns that disrupt sound. But beneath that busy upper layer, the water becomes calmer. The deep, cool regions act like a soft acoustic roadway. A whale song released at the right depth can follow this roadway effortlessly, needing no additional force to keep moving. The sound becomes a quiet traveler carried by the sea's natural architecture. Whales seem to know this instinctively. Some species dive to reach the perfect layer before singing. They glide downward until they find the calm zone where the water density supports clean, long-distance sound. Then, they release a slow note that rolls outward, far beyond the reach of any single individual's vision. It may pass over underwater canyons. It may slip along deep ridges. It may curve slightly as the temperature changes, yet it keeps moving, patient and unhurried. Imagine now a listener far away. Perhaps a blue whale rests hundreds of miles from the singer. The water around it is still. A faint vibration enters its world, so faint that you or I would never notice it. But the whale feels it. Deep within its skull, specialized bones vibrate in response. The tone is recognized as whale language, even though it has wandered a remarkable distance. The receiving whale may respond with a note of its own, sending its voice back along the same quiet path. These exchanges can occur between whales who never see one another. The ocean is too vast, the distances too great for sight to serve as a reliable way to navigate or communicate. Sound becomes their connection, allowing individuals to coordinate movements, share information, and maintain awareness of distant neighbors. Even when separated by a space larger than the distance between coastal cities, whales remain part of an acoustic community that spans the deep ocean. Consider for a moment the emotional dimension of these long-distance songs. To us, they sound lonely, soft calls drifting through the darkness, sent from one unseen being to another. Yet whales may not feel loneliness the way humans do. Their songs create connection. Their voices fill the deep with presence. A whale may drift for hours in dark water, knowing it is not alone, because it hears a faraway call weaving through the ocean like a familiar thread. Long-distance singing also supports migration. Many whales travel thousands of miles between feeding and breeding grounds. Along these routes, ocean conditions shift and underwater geography changes shape. But sound remains a dependable guide. A distant call might reveal the presence of others following the same path. A sequence of tones might signal shallow water ahead, or a preferred channel for moving through unfamiliar regions. Scientists studying these songs have made fascinating discoveries. In some cases, hydrophones, underwater microphones, have detected whale calls echoing across ocean basins. A call from one region may be picked up incredibly far away, sometimes near another coastline entirely. These observations reveal just how powerful and far-reaching whale voices can be. A single note can linger in the water long after the caller has moved on. Imagine drifting in that deep stillness. You hear a low moan that seems to come from everywhere at once. It feels more like a mood than a sound. Soft and steady, rolling outward, expanding. That is what a long-distance whale call is like. It becomes part of the ocean itself, shaped by its quiet layers, carried by its currents, reflected softly by underwater slopes, and stretched into something peaceful and atmospheric. We often think of the deep ocean as silent, but in reality, it is filled with these gentle voices. They are slow. They are soothing. They drift through miles of water without urgency. They move with the pace of the sea, which has no need to hurry. To listen to a whale song is to hear time slowing down. Each note seems to stretch, as though inviting the listener to breathe more slowly, to settle more deeply, and to rest more fully. When whales sing across such great distances, they also create a kind of underwater map. The return of an echo can reveal the presence of a seamount or a submerged ridge. Whales may sense the slight distortions caused by these reflections. These acoustic clues guide them through areas that would otherwise be difficult to navigate in near darkness. It is as if the ocean whispers back to them, offering gentle hints about the geography hidden below. Long-distance singing is also a way whales express presence. A deep moan might signal territory. A slow rumble might indicate readiness for mating. A sequence of rising tones might invite others to gather. Each song carries layers of meaning shaped by the physical nature of the sea and the cultural traditions of the species. As you drift deeper into rest, imagine these long-distance calls moving around you like low, soft waves. Picture them rolling through dark blue water. Picture them passing under vast stretches of open ocean. Picture them gliding along underwater pathways shaped by warm and cold layers. These are the gentle messages whales send across the world, messages delivered not by sight or touch, but by sound, moving patiently through the deep. Let that calmness fill you. Let the slow, steady rhythm of these calls help your thoughts grow quieter. In the next chapter, we will explore how the geography of the seafloor shapes these wandering voices even further. Settle softly into this next journey as we drift down toward the deep ocean floor, a vast landscape hidden beneath layers of calm blue water. Down here, The world feels ancient. It is shaped by slow-moving forces that take millions of years to carve underwater valleys, raise long ridges, and form sweeping plains of fine sediment. These features do more than support marine life. They also shape the movement of sound. They help guide whale songs through the depths, bending and reflecting gentle notes in ways that create a complex and peaceful, underwater acoustic world. Imagine the seafloor spreading out beneath you like a continent sculpted into shadows. There are wide areas as flat as open plains. There are tall underwater mountain chains that stretch for hundreds of miles. There are steep trenches that drop far deeper than the height of many land peaks. Each of these shapes influences the way sound moves. Each one adds character to the ocean's natural acoustics. Picture a whale drifting above one of these underwater plains. The smooth surface below it reflects sound upward in broad, even waves. A low call moves outward, rising gently from the sea floor. The note keeps its shape, its rhythm, and its softness because the plane offers a stable, predictable reflection. A distant whale listening to this call may sense the presence of such a plane simply by noticing the clean, smooth quality of the sound as it arrives. Now imagine a different scene. A whale glides above a long chain of underwater ridges. These ridges act like a series of subtle echo points. A call released here may bounce more than once before reaching a listener. Each reflection may slightly lengthen the sound. It may soften the edges of a note or blend certain frequencies. To the whales, these small shifts become clues. They reveal the shape of the geography beneath them. They help the animals understand where they are, even when traveling in very deep and very dark water. In regions where the seafloor rises gently, long-distance whale songs may travel farther. The sloping ground can act like a natural acoustic ramp, supporting a call as it moves outward. But in areas where the seafloor rises sharply into submerged cliffs, the echoes become more complex. The sound may scatter slightly or reflect back at unusual angles. Whales seem to understand these variations instinctively. They adjust their calls. They reposition their bodies. They choose depths where the reflections become most helpful. Now picture a deep ocean trench. Its walls rise steeply on either side, like the edges of a massive canyon. A whale releasing a call inside such a trench may produce tones that travel upward, downward, and sideways in unusual patterns. Some of the sound may echo inside the trench before escaping. Some may travel along the length of the trench like a long, soft breath moving through a tunnel. These environments can amplify low-frequency sounds in remarkable ways, making the deep ocean feel like an enormous, resonating chamber. These underwater lands are not still. They shift slowly over time as tectonic plates move. These movements can change the shape of underwater ridges or alter the depth of wide plains. As the geography transforms, so does the acoustic personality of the ocean. Whales, with their long migrations and deep sensitivity to sound, experience these shifts over generations. Their songs may adjust to match new acoustics. Their traditions may migrate with them as the underwater world slowly reshapes itself. Imagine a whale traveling across thousands of miles during a long migration path. The ocean floor beneath it rises and falls in sweeping patterns. Mountains pass beneath its belly without ever breaking the surface. Plains stretch outward like hidden deserts. Deep valleys open suddenly into vast blue emptiness. Through all of this, the whale listens. The faint echoes of its own calls bounce back, whispering information about the landscape below. In this way, whales map their world through sound, repeating checks and adjustments as they glide through the deep. In some regions, the seafloor features help create what scientists call acoustic shadow zones, areas where sound does not travel easily. Imagine a whale singing above a ridge. The ridge might block the downward movement of the call, creating a quiet pocket behind it. Another whale inside that shadow may not hear the call at all. Instead, it may rely on echoes bouncing from different angles or choose a new depth to escape the shadow. These subtle choices reveal how deeply whales understand the shape of their environment. Picture now a group of whales moving along underwater valley. The valley amplifies the group's soft calls. Their voices reach one another easily, even across many miles. This shared acoustic space allows them to maintain contact despite darkness or distance. Their slow, rumbling tones drift along the valley walls, echoing in warm and calming patterns. The whales travel together through the deep, guided by their voices and the geography that shapes them. Even the texture of the seafloor matters. A rocky bottom may create sharper reflections, adding crispness to certain notes. A soft, silty plain may absorb some sound, smoothing the tone and softening the edges. These differences give each region its own acoustic fingerprint. A whale that has traveled through many places may recognize these differences just as a human traveler recognizes changes in landscape or climate. The ocean floor also influences how whale songs rise toward the surface. In some areas, reflected sound meets warmer layers above, refracting upward into shallower water. In other places, the shape of the land below pushes the call downward, deeper into cooler, denser layers where long-distance travel becomes more effective. Whales use these behaviors to decide when to dive and when to rise while singing. They choose the depth that best carries their voices toward their intended listeners. All of this happens silently from a human perspective. We do not see the reflections. We do not feel the low vibrations bending through deep layers. But to whales, the entire underwater world is full of these gentle, informative signals. Their songs interact with the seafloor constantly, weaving patterns that reveal hidden geography and help guide their long journeys. As you rest, imagine drifting above this quiet, shadowed world. Picture long ridges stretching beneath you like ancient stone waves. Picture wide plains glowing faintly with filtered light from far above. Picture deep trenches falling away into cool, endless blue. Endless blue. Now imagine a whale's song traveling through this landscape. Slow, steady, peaceful. guided by the geography of the sea. The sound bends, reflects, and drifts, shaped by features far below. Let this image soften your thoughts. The ocean floor, unseen by most of us, is a calm and patient sculptor of sound. Its ridges and valleys guide the voices of whales, helping them create the serene soundscape that fills the deep. As you drift toward deeper rest, let the quiet movement of sound through this ancient underwater world soothe you. Take a soft breath as we enter the quiet hours of the ocean. Night in the sea is different from night on land. There are no streetlights, no glowing windows, no distant hum of traffic. Instead, darkness settles over the surface like a vast, gentle blanket, and the world below adjusts with slow, drifting rhythms. Many creatures become active. Others grow still. And within this shifting calm, whales move through a soundscape shaped by the quiet patterns of night. Imagine floating just beneath the surface after sunset. The last hints of daylight fade, turning the water into dark layers of blue and soft shadow. The surface grows quieter as waves settle and wind eases. Tiny plankton begin to drift upward, forming thin, shimmering clouds. Fish rise from deeper areas to feed. The ocean transforms into a place of subtle motions and soft, rhythmic sounds. In the darkness, whales navigate with an ease that comes from millions of years of experience. Sight matters less now. Sound becomes their primary guide. Even faint vibrations travel cleanly through the cool nighttime water. A distant call becomes clearer. A soft echo from the seafloor returns with slightly more definition. Everything in the ocean seems to quiet itself, so voices can pass more easily. Some whales rest during these hours, while others continue to travel or feed. Rest for whales is unlike rest for humans. They do not sleep the way land mammals do. Instead, they enter a state of gentle partial rest, where only part of the brain relaxes at a time. This prevents them from losing awareness of the world around them. Even when resting, they must occasionally rise to breathe. It is a calm, slow cycle drift. Breathe, drift again. Picture a large whale floating in the dark, its body still except for the soft sway of currents brushing past. Its eyes may close halfway. Its heartbeat slows. It stays near the surface, where a gentle upward drift helps bring it back to air when needed. In this restful state, the whale's mind quiets, yet it continues to hear the world around it. Soft clicks, low rumbles, faint, distant calls. They all weave together into a nighttime lullaby that wraps around the resting whale like a warm blanket. Now imagine a pod of whales resting together. They drift in loose formation, their bodies spaced comfortably apart. Each whale listens to the gentle sounds shared between them. These soft calls help maintain a sense of closeness even when the ocean grows dark. A mother may emit a quiet hum to her calf, guiding it as they float. The calf, comforted by the rhythmic tone, drifts into its own form of rest. This bond remains strong through the night, carried entirely by sound. Nighttime brings a different acoustic personality to the sea. Many marine animals become more active in the dark. Shrimp crackle softly in the shallows. Tiny fish rustle as they move in schools. Some larger species create soft pulses or clicks as they hunt. All these noises blend into a peaceful underwater background hum. It is not loud. It is not chaotic. Instead, it becomes a gentle texture behind the deeper voices of whales. Scientists describe this nightly rise in activity as a vertical migration, the largest movement of life on our planet. Countless small organisms rise from deep water to feed near the surface during the dark hours and then sink again when the sun returns. Their bodies, though tiny, create subtle movements and vibrations. Whales pay attention to these patterns. A shift in the way small fish scatter might tell them about predators nearby. A change in plankton movement may indicate a current shift. The night becomes a time of acoustic awareness. Some whale species take advantage of the darker hours to feed. With the cover of night, prey may gather more densely. The calm sea helps whales hear faint cues that reveal the position of food. A quiet click from a distant hunting whale may echo through the darkness. A soft whoosh of movement might signal a large school of fish. Each sound helps guide whales toward the nourishment they need for long migrations and energetic songs. Other species use nighttime for social behavior. Humpback whales, known for their long and complex songs, sometimes increase vocal activity in the dark. Their notes drift upward through the quiet water, spreading outward with fewer disturbances than during the day. These nighttime songs may serve multiple roles, maintaining social bonds, attracting mates, or offering acoustic anchors that help whales keep track of one another as they rest or travel. Now imagine a moment deep in the night when the ocean becomes particularly still. The water feels heavy with quiet. A single whale begins to sing. The low notes rise slowly through the dark layers. Each tone carries for miles without interruption. The song becomes part of the seascape, stretching outward like a calm blue ribbon. Other whales hear it, even if they are far away. The song guides them. It reassures them. It becomes a presence in the darkness. Whales are not the only ones who sing at night. Some fish produce rhythmic pulses to attract mates. Others make soft grunting noises when startled. Even small crustaceans contribute to the nighttime chorus with tiny crackling sounds. Yet, the whales' voices remain the deepest and most soothing. Their songs weave through the other noises, forming a slow foundation that anchors the entire underwater soundscape. Consider how the temperature of the water changes after sunset. As the surface cools, the upper layers shift slightly, altering the way sound travels. Sometimes this cooling creates clearer pathways, allowing calls to travel farther. Other times, it enhances gentle echoes, softening the edges of each note. The nighttime ocean becomes a dynamic acoustic field, shaping whale songs into new forms with each passing hour. Picture yourself drifting through this world. You hear soft pops from tiny creatures nearby. You hear faint rustling from fish moving through dark water. You hear the slow pulse of a distant whale call, thick and resonant, It echoes through the deep, carried by cool layers that form a natural sound channel. These overlapping sounds create one of the most peaceful soundscapes on Earth. Whales experience emotion through these nighttime patterns. A mother whale may hum softly to her calf as they rest. Adult companions may share gentle contact calls to maintain their bond. A solitary whale traveling long distances may release a quiet moan simply to feel the presence of its own voice reflecting through the water. These sounds bring comfort. They create connection. They make the dark sea feel less empty. As you relax into this calm chapter, imagine the ocean at its stillest. The sky above is dark. The sea below is quiet. Whales drift peacefully in slow, rhythmic breaths. Their soft calls move through the water like ancient lullabies shaped by millions of years of learning. They are the night singers of the deep, keeping company with the stars overhead and the gentle creatures rising from below. Let your breathing soften as we drift deeper into the quiet layers of the ocean, where the darkness becomes velvety and the water grows cool and still. In this chapter, we gently explore the surprising truth that whales are not the only singers of the sea. The deep ocean is a world filled with voices, some familiar, others unexpected, all contributing to a peaceful underwater symphony that has echoed across the planet for millions of years. Imagine drifting through the deep at night, surrounded by blue-black water that stretches in every direction. Somewhere far away, a humpback whale releases a long, smooth note. But below that call, and above it, and around it, there are countless other sounds. Some are faint clicks. Some are rhythmic pulses. Some are gentle hums or soft crackles. Together, they form one of the richest and most mysterious soundscapes on Earth. One of the most surprising contributors to this nighttime music comes from a creature far smaller than whales. Picture a humble fish called the toadfish resting near the seafloor. Though small, it has a remarkable ability. Male toadfish create long, vibrating hums to attract mates, producing sounds that can last for many seconds without breaking. These hums can resonate through shallow bays, sometimes even vibrating boat hulls resting above. To whales, these hums may be barely noticeable in deeper water, but they add a soothing background tone to coastal marine life. Now glide away from shallow grounds and journey toward deeper water. Here you may hear patterns of steady drumming created by certain species of drumfish. Their bodies contain specialized muscles that vibrate against their swim bladders, producing rhythmic pulses that travel cleanly through water. These pulses are calm, steady, and deeply atmospheric. While these fish are not singers in the same way whales are, their unique sound-making organs help shape the ocean's acoustic identity. Continue drifting, and you may encounter a surprising group of singers, shrimp. Though they are tiny, some species produce rapid crackling sounds that create a distant sizzling texture in underwater recordings. These noises come from quick snaps of their claws, which produce tiny pockets of energy. The result is a soft, crackling chorus that fills warm coastal areas at night. To a whale passing by, this may feel like drifting through a gentle acoustic mist, a hazy background texture of tiny snaps echoing through shallow water. Now move into deeper and colder regions, where bioluminescent creatures drift like floating stars. Among them are certain species of squid and cuttlefish that create soft vibrations when they move. These vibrations are not exactly songs, but they are rhythmic and steady, adding subtle layers to the ocean's nighttime symphony. When these creatures gather in large numbers, the combined vibrations form a faint hum that may stretch across wide sections of deep water. Some of the most unusual underwater voices come from creatures that do not use vocal cords at all. Picture a large grouper resting near a coral formation. When startled or when communicating with a mate, it may release a low-frequency thump produced by contracting specialized muscles. These thumps can travel surprisingly far and may be heard by whales moving through nearby waters. In these moments, the grouper becomes part of a larger soundscape, its deep knocks blending with the slow rumble of whale calls. Continue drifting deeper into the twilight zone where sunlight no longer reaches. Here, lanternfish move in great shimmering clouds. They are among the most abundant vertebrates on Earth, and they produce soft clicking sounds as they feed and swim in groups. These faint clicks contribute to the quiet nighttime chorus of the ocean, becoming part of the vast acoustic environment whales navigate. Some of the most mysterious sounds in the ocean come from unknown sources. Scientists using hydrophones have recorded humming tones, rhythmic pulses, and slow oscillations that do not match any known species. Some of these sounds may come from large fish. Others may come from shifting currents or underwater geological activity, but a few remain unexplained. Whales and other animals hear these sounds long before humans do. To them, these mysteries become familiar parts of the underwater world. Whales share this soundscape with grace. They do not dominate it. Instead, their calls rise and fall within it, creating a slow, calming foundation beneath all the smaller noises. Imagine a blue whale releasing a deep call. The note travels outward, weaving through the crackles of shrimp and the hums of fish. Instead of drowning them out, the whale's call blends with them, becoming part of an intricate tapestry of underwater sound. Even tiny plankton contribute to the quiet music of the sea. Some species produce faint popping noises as they move or as gas bubbles shift around their bodies. These sounds are extremely soft, but in large numbers, they create a subtle whispering texture. Through the deep hours of the night, the movements of plankton form a continuous, almost meditative backdrop. Whales navigating through these waters experience a world filled with gentle, ever-present sound. Another surprising singer of the sea is the bearded seal. Males produce long, descending whistles during mating season that can travel great distances through icy northern waters. These whistles rise into the darkness like soft falling notes. They are much higher in pitch than whale songs, but no less calming. To nearby whales, these seal voices are distinct yet harmonious, adding bright tones to the deeper marine soundscape. As you drift through this imagined underwater world, picture yourself surrounded by layers of sound. Low whale calls roll outward like slow waves. Higher-pitched seal whistles drift above them. Fish hums and pulses create a steady heartbeat in the background. Tiny crackles from shrimp sparkle through the mix like distant stars, and the faint rustling of countless creatures adds a soft texture beneath it all. This symphony does not follow a single rhythm. It is shaped by the movements of life, the rise and fall of tides, and the steady cycling of day and night. Even when no whale is singing, the ocean never becomes silent. It speaks softly through its creatures, sending gentle vibrations through every corner of the deep. Whales live their entire lives within this acoustic world. They use it not only for communication, but for navigation, feeding, bonding, and comfort. They understand the patterns of nighttime sounds, the shift in tones when fish gather, and the faint changes that signal migrating prey or shifting currents. To them, the ocean's chorus is not background noise. It is a map, a lullaby, a companion. As you relax, let yourself imagine being part of this quiet seascape. Feel the calm flow of sounds around you, the soft crackles, the faint hums, the deep calls rolling through the dark water. All of it blends into a soothing symphony that has existed long before humans ever listened. And tonight, it guides you gently toward rest. Let your breath soften as we drift into a chapter filled with quiet wonder and gentle discovery. Tonight, we explore how scientists listen to the deep ocean, gathering the faint voices of whales, fish, and countless other creatures. The deep sea holds sound the way a still night holds distant echoes. With patience and delicate instruments, researchers learn to interpret these underwater messages, revealing hidden stories of migration, communication, and ancient acoustic pathways carved by nature itself. Imagine a calm ocean at dawn, the surface smooth like brushed silver. Far below, scientists have placed a small instrument called a hydrophone, a device designed to record underwater sound. A hydrophone is simple in shape, often no larger than a small canister. But what it captures is extraordinary. It listens to the deep as if it were an open microphone placed in the largest concert hall on Earth. Every hum, rumble, pulse, and whisper becomes part of its recording. Some hydrophones rest only a few feet below the surface. Others are lowered into deep water until they float far beneath the waves, anchored by weighted lines. In certain regions, hydrophones are placed so deep that they rest near cold, quiet layers, where sound travels for miles. These instruments hear what humans cannot. Distant whale calls drifting through the deep, hidden rhythms from migrating fish, and the slow crackle of tiny creatures moving through dark water. Imagine now a scientist sitting in a warm research vessel. The deck rocks gently. The room around them is dim. A soft glow from monitors lights their face. Through headphones, they listen to the hydrophone's feed, a world of underwater sound rising gently from the deep. At first, they hear nothing but soft static. Then a low, steady moan appears, stretching across the recording like a calm wave. The scientist knows this tone. It is the voice of a whale traveling somewhere far from the boat. These recordings allow scientists to track whale movements across great distances. A single hydrophone might detect calls from whales separated by many miles. By placing multiple hydrophones in different locations, researchers can triangulate the whale's position, much like using distant lighthouses to determine a ship's location at night. Over time, they build maps of migration paths, showing how whales travel through the ocean's long, quiet corridors. Some whales leave distinct acoustic signatures, unique features in their calls that act like individual fingerprints. A researcher listening closely may recognize a familiar pattern from a whale recorded years earlier. These returning voices help scientists understand family relationships, communication habits, and long-held traditions passed down among whales. Now picture a deep-water research station far from land. In some remote areas, hydrophones are attached to long cables suspended in deep blue layers. These stations record sound continuously, sometimes for months or years without interruption. When the data is retrieved, it contains a vast timeline of the ocean's acoustic life. The slow rhythm of seasons becomes audible. Storms appear as rushing low-frequency bursts near the surface. Shifts in currents create subtle changes. And through it all, whale songs weave soft patterns across the recordings. Scientists also use traveling gliders, quiet, torpedo-shaped instruments that drift through the ocean following programmed routes. They move slowly, using minimal energy, and carry hydrophones along with them. These gliders listen passively, gathering sounds as they drift hundreds of miles through quiet water. They record calls from whales the researchers will never see in person. They sample entire soundscapes across regions too vast for a single ship to explore. Imagine one of these gliders moving through cool, deep water. It hears a soft, rising call from a humpback whale. It hears a distant moan from a blue whale far beyond the horizon. It hears the quiet popping sounds of small creatures migrating upward for their nighttime feeding. Every sound becomes part of its onboard memory, waiting to be retrieved and studied. Whale songs are not the only things scientists discover. Some hydrophones have recorded mysterious underwater sounds with unknown origins. Long, steady hums, rhythmic pulses, soft oscillations that rise and fall like distant chants. Some of these sounds may come from deep-sea fish. Others may be the echoes of distant ice cracking or underwater geological shifts, but a few remain unexplained. These mysteries remind scientists that the ocean is far larger and more complex than any instrument can fully capture. Scientists also learn about the health of whale populations through sound. When calls become more frequent in certain regions, it may indicate the arrival of migrating groups. When calls decrease, it may signal a shift in habitat or a change in feeding patterns. Acoustic research helps scientists protect whales by identifying important areas where the animals gather, rest, or sing. Imagine now a researcher listening to a recording of an area known for whale activity. The recording begins with faint crackles, then soft groans from distant whales. Suddenly, a long, haunting note rises through the audio, a humpback song echoing through miles of deep water. The song fluctuates gently, rising and falling in calm, deliberate phrases. The scientist marks the time and direction. This information will help identify where the whale traveled and how long it stayed in the region. Some scientists study the ocean's soundscape as a whole rather than focusing on individual animals. They listen to how natural noise changes over time. They track how storms, shifting currents, and seasonal migrations alter the underwater environment. Through these studies, they build a deeper understanding of how sound moves through warm and cold layers, how geography shapes echoes, and how whales adapt to these changes. The deep ocean is so vast that even with many hydrophones, scientists hear only a small portion of its acoustic world. Yet, this portion reveals an extraordinary truth. The ocean is always speaking. Its creatures, its currents, its shifting layers, and its geography all produce sound. Scientists are simply learning to interpret this ancient language through careful listening and gentle patience. Imagine the soundscapes scientists hear when they play back hours of recordings. There are long stretches of silence, broken by soft pulses. There are sudden rising whistles from passing dolphins. There are gentle hums from schooling fish. There are faint tremors from distant underwater features, shifting slowly over time. And weaving through that entire tapestry, there are whale songs, rolling, calm, patient voices that glide through the deep like slow-moving lanterns. In the quiet of a research room, these sounds can create a serene atmosphere. Scientists often describe listening sessions as meditative. The ocean's rhythms calm the mind. The long, slow tones of whales feel soothing even through speakers. The deep sea, though vast and often mysterious, communicates in a language that is gentle and deeply peaceful. As you drift into rest, imagine yourself wearing those headphones. You hear a faint rising tone, then a low moan. Then the soft echoes returning from underwater ridges. You listen to the deep ocean the same way a scientist would, patiently, curiously, calmly. And in that listening, you find peace. Settle deeper into stillness as we drift into the final chapter of our underwater journey. Tonight, we explore a gentle mystery that connects the human mind with the ancient rhythms of the sea. Why the sounds of whales and the ocean are so deeply calming. For reasons shaped by biology, memory, and the physics of sound, the ocean's voice has a remarkable ability to quiet our thoughts and guide us toward peaceful sleep. Imagine yourself listening to a slow whale call. The note rises gently, holds for a moment, and then fades into the deep. It has no sharp edges, no sudden bursts, no urgent message, just a long, soft, resonant tone drifting through the water. Human ears respond to this kind of sound with a sense of safety. The brain recognizes low, steady frequencies as signals that the environment is calm. In nature, sharp or high-pitched sounds often warn of danger, but long, low tones tell the body that nothing threatening is near. They help the nervous system slow down and settle. Ocean sounds also mimic the rhythms humans first heard, long before birth. Inside the womb, a developing baby hears the steady pulse of a parent's heartbeat and the soft rushing of fluid moving around them. These are low-frequency, continuous sounds shaped by liquid, not air. When adults hear ocean waves or whale calls, something deep in the mind may recognize these early, soothing patterns. The ocean becomes a reminder of a time when life felt safe, warm, and unhurried. Now imagine the sound of gentle waves moving across a shoreline. Each wave rises slowly, reaches its crest, then breaks into a soft rush. The cycle repeats with steady predictability. This rhythm is neither too fast nor too slow. It matches a pace the human mind naturally finds restful. When you listen to waves, your breathing begins to follow their timing without effort. Your inhale rises with the wave. Your exhale softens as the water pulls back. This natural synchronization helps prepare your mind for sleep. Whale songs add a layer of depth to this peaceful rhythm. Their low-frequency notes create a kind of acoustic massage. These sounds can cause tiny vibrations in the chest and throat. Even when played softly, the body responds with relaxation. Muscles loosen, heart rate slows, the mind grows quieter. This is not imagination. It is biology responding to sound. Scientists studying the effects of sound on sleep have discovered that slow, continuous tones help encourage the transition from wakefulness into the first stages of sleep. The brain moves rhythmically between different electrical patterns, and steady low-frequency sounds support these shifts. The long, rolling nature of whale songs matches the timing of the brain's early sleep waves. This is one reason why such sounds feel dreamy, soft, and deeply comforting. The ocean also calms the mind because its sounds lack strong patterns. They are steady but unpredictable in small ways. No two waves sound exactly the same. No two whale songs are perfectly identical. This soft irregularity keeps the mind gently engaged just enough to prevent spiraling thoughts while still encouraging relaxation. The result is a peaceful mental drift. Your thoughts float, loosen, and fade into the background. Imagine yourself lying near a calm nighttime shore. The air is cool. The sky is wide. Each wave rolls in with a soft hush, followed by a faint, retreating whisper. These sounds do not demand attention. They do not overwhelm. They simply exist, steady and patient. Listening to them is like listening to breath, slow, rhythmic, soothing. In this slow rhythm, the mind releases the day and allows the body to rest. Now, imagine listening to a humpback whale song in the background. Its long notes stretch through darkness like gentle beams of sound. They move with the same slow pacing as waves, but reach deeper. The ocean becomes a layered lullaby. Waves at the surface, whale calls far below, and the soft crackling of tiny deep-sea creatures in the distance. These layers form one of the most calming natural soundscapes on Earth. Humans have always been drawn to the sea. Even those who have never visited an ocean often feel a sense of peace when imagining it. This connection may come from the way the ocean represents vastness, continuity, and timelessness. The horizon where sea meets sky suggests infinite calm. The rolling water reflects the passage of time. Whale songs drifting through deep layers remind us that life existed long before us and will continue long after. These ideas help place our own worries into perspective, making them feel smaller and easier to release. Listening to ocean sounds also activates parts of the brain associated with imagination and memory. You may picture drifting through deep blue water. You may imagine floating near a calm shore with moonlight shimmering across the waves. These imagined scenes create emotional calm even when you are far from the sea. In this way, ocean sounds become both a physical and a mental gateway to rest. Another soothing effect comes from the way water supports vibration. Underwater sound is rich, full-bodied, and continuous. When played through speakers or headphones, recordings of whale songs carry some of this fullness. The tones feel round and enveloping, almost as if the listener is being gently held by the sound. This quality can ease tension in the mind, much like a slow, comforting embrace. The deep ocean, with its layered soundscape, also helps the mind release its sense of urgency. The brain is always searching for patterns that require action. But the ocean's sounds offer no such signals. They simply drift. They encourage the listener to drift as well. Thoughts become slower. Worries soften. The mind follows the pace of the sea. As you relax, imagine hearing a distant blue whale call. The note is low and steady. It rolls through the water like a slow vibration. Each rise and fall mirrors the natural rhythm of a calm human breath. You inhale as the sound expands. You exhale as it fades. The body responds instantly, sinking deeper into comfort. Consider, too, the way whale songs carry a sense of gentle mystery. There is something peaceful about hearing a voice that originates far away from a creature enormous and ancient, moving through a world we cannot see. This sense of the unknown, soft, slow, and safe, helps quiet the part of the mind that seeks answers. It encourages surrender. It guides you into rest. When you listen to the ocean, whether through recordings or in memory, you hear more than sound. You hear stability, continuity, rhythms older than human civilization, patterns shaped by currents, tides, moon cycles, and the paths of migrating whales. These natural elements work together to create an environment of deep calm. As you drift toward sleep, let yourself imagine floating through that calm world. The ocean below is cool and quiet. The sky above is soft and wide. A slow whale call drifts through the water, guiding you like a gentle beacon. The waves follow a patient rhythm, rising and falling with your breath. In this peaceful scene, the day releases you. The night welcomes you. And the ancient voices of the ocean guide your mind toward rest, one soft, steady tone at a time. Let your mind drift as we rise gently from the deep ocean, carrying with us the soft voices and slow rhythms that have shaped our journey tonight. We have traveled through ancient whale lineages, through sound channels shaped by warm and cold water, through vast undersea landscapes where songs drift for hundreds of miles, and through the quiet nighttime world where whales rest and sing beneath the stars. Now, as we return toward the surface, the ocean leaves a peaceful imprint behind, calm, steady, and filled with quiet wonder. Imagine yourself floating near the top of the sea. The water is cool and still. Far below, the last faint echoes of whale songs rise like distant memories. Each tone carries the weight of millions of years of evolution, yet it feels gentle, timeless, and soothing. The ocean has a way of slowing everything down. Even thoughts that once felt heavy now drift lightly, carried by calm currents of deep blue stillness. You remember the surprising creatures that add their voices to the underwater world. The hums of fish, the delicate snaps of small crustaceans, the soft vibrations of drifting life. All of them weave together into an acoustic tapestry that never stops, even in the darkest hours of night. It is a reminder that the ocean is never truly empty. It is alive with subtle rhythms and ancient stories. You also remember how scientists listen to this hidden world, gathering whispers from the deep to understand the movements and traditions of whales. Their instruments capture what human ears were never meant to hear, gentle calls traveling across miles of quiet water. Through these recordings, we are allowed a small glimpse into a world that remains mostly unseen, yet always full of beauty. As you settle into the final moments of this calm journey, imagine the ocean spreading outward around you, wide and endless. The surface glows softly in the fading light. A slow wave rises, then falls. Somewhere far below, a whale releases one last deep, rolling call. It drifts upward through cool layers, a peaceful reminder that the ocean watches over itself with steady patience. Let that calmness follow you into sleep. Let the quiet memory of the sea rest gently in your mind, and let its ancient songs guide your dreams, one soft breath at a time.